What happens to the grid when 20 electric machines start charging in a mine with no warning? Picture it. You're deep underground, the environment is enclosed, and you're fully relying on the local systems. Suddenly, a fleet of electric machines plug in all at once, charging, demanding energy. What does the grid do? Can it keep up, or does it risk collapse? This question is one of the reasons why I'm here today, and it's what we've been doing for a while now with the Subspace Energy Hub. My name is Aurora Puriqi, and I'm the Business Development Manager for the Subspace Energy Hub. Subspace Energy Hub is a platform, it's an international platform dedicated to the decarbonization of underground spaces. We are implemented at the Hagerbad Test Gallery, which is a testing facility located in Flums area in Switzerland. It's a 5-kilometer tunnel, which is a full infrastructure where various types of testing, R&D, and technology development can be done. And it has a history of over 50 years. And it's a recognized research facility of national importance. So Hagerbad is the test bed for Subspace Energy Hub projects, but not only, we also use other facilities to test our projects and implement our projects. This is just our main one, but the Subspace Energy Hub is bigger than the Hagerbad. We are, as I said, an international platform that runs by memberships. We, at the moment, have 17 member companies that are very diverse stakeholders of the industry. And once the companies become members of the Subspace Energy Hub, we start activating them in projects in each of our work streams. At the moment, we have 6 work streams where we operate or we focus our projects and activity. Electrification, DC microgrid topic, energy storages, including compressed air, battery, heat, also hydrogen, but hydrogen we have put it separate because it had higher interest in the beginning, safety and risk management, and net zero construction sites. So as you see, the majority of our work streams are areas of operation also for the mining industry. Our mission with the mining industry is simple. We want to support the full transition to intelligent, autonomous, and electric mines. But we know that this transition is not only about the machines. It requires a full system to support it. So we want to make sure that these systems, especially the energy systems, are ready. We are at the tipping point with the mining industry and the mining electrification. Heavy fleets are switching to BEVs, and the OEMs are delivering the hardware. But here's the catch. The infrastructure is not ready. Mines operate as energy islands. They are isolated, remote, and not really prepared for the energy demand that switching to BEVs would require in a while. So we're seeing a fragmentation of efforts, lots of pilots, lots of machines, but very few projects are looking at the full picture and the full system. That's where the Subspace Energy Hub comes in. And we are trying to shape that foundation with our innovation ecosystem. So what do we actually do? As I said, we are a platform, but we also are very hands-on and very pragmatic by using our infrastructures to actually implement projects. We are serving as a catalyzer for the industry, for all the stakeholders, to first bring them together, sit together, talk together, discuss projects, initiate projects, start solving and implementing projects on a bigger scale, testing them and showcasing them on a smaller scale in the beginning. So then these solutions can be implemented on a bigger scale elsewhere, like in a mining environment. So we are serving as that catalyzer that brings all the stakeholders in. But what is unique about us is, as I said, we have this network of companies that is constantly growing and expanding. We have the infrastructure, which is the Hagerbad Test Gallery, but we also partner with other infrastructures that are similar or elsewhere because from our network again. So we have these facilities, we have the network, we have the reputation, we have the know-how and the experience in the industry because Subspace Energy Hub was founded by senior and renowned leaders of the industry from the OEM side, from the tunneling side, and from the mining side. By the way, Normet is also part of the Subspace, so we're very happy to have them on board. And what we're doing at the moment and where we're focusing is we're very active with energy storage testing and demonstration pilots. We're very active with heavy fleet and autonomous charging design cases, grid balancing scenarios, collaborating closely with OEMs for battery longevity, safety, and charging. In general, we're building this intelligent power and networking system that the mining industry will make use of. Today, I wanted to bring one of our case studies or projects that we've been working on that I started in the beginning with that open question. So this is a case study we started a few months ago, and it's about optimizing electrical grid stability for high-density BEV charging in mine sites. And in this case, we have collaborated with this mine in Finland, Kallio Mine, which is a partner of the Subspace Energy Hub, and we have a shared offering with them. So we are using this environment to showcase this project and this concept. The idea for this project came exactly from talking to OEMs, talking to the mining industry, listening to their needs, their concerns, and that's what we do with the Subspace Energy Hub. We bring the people together, we listen, and we identify problems that we might come closer with our solutions. The goal of this project is to understand the BEV charging effects on local grids in high demand, because this is something that is going to happen sooner or later, and we want to make sure that the solutions and the efficiency are there. So it matters because traditional grids are not built for modern BEV electrification loads. They are still not that sophisticated, and uncontrolled BEV charging can lead to grid failures, energy losses, and downtime. This project aims to address these key research questions. The first one is about bridging the data gap in mine electrification. As I said, we're seeing fragmentation of efforts, and no one has the full picture, but that also works in terms of data. From our daily interactions with all these companies, we know the OEMs have their own data. We all know the mining companies have their own data, or different technology companies measure their own data. But when it comes to integrating everything together and seeing the full picture and the full puzzle, that's where it gets a bit messy. So these answers could be given by implementing such a project and testing it and implementing it on a real site. Also, another research question that needs to be addressed is tackling the energy system bottlenecks, identifying critical roadblocks in the energy infrastructure that are slowing down the electrification in a mine, and also identifying solution for unified transition, which means what type of energy systems, what type of renewables to be implemented and to best support the high demanding charging. How we plan to do this? At the moment, we are still at the infancy of this project, of course. We have the structure, we have the working groups, we've had the previous discussions, and we are still, we have at the moment 8 companies that are involved in this discussion since the beginning, but we are very interested to have more companies involved if that could be possible, and this is one of the reasons why I'm here today. We're open to having more companies like mining companies or technology companies that would like to be involved and contribute to this project. And just to give you some information about the structure of it, we plan to do the site assessments and gathering data from both sites, the Hagerbates Gallery, which is the facility that I mentioned. It's representing a construction site, and then the Kallio Mine, which represents a full real mine site. Kallio Mine also has a 5G network, which means they have a very sophisticated monitoring system in-house. Then after the data, we are planning to do the grid simulation, doing various type of simulation for different scenarios, for different parameters to see the grid behavior. And then designing solutions, evaluating the energy solutions that could be implemented, or the systems or renewable integration or dynamic load systems. And then pilot testing it and monitoring solutions on sites. What we expect, maybe we will have a real insight solution in a nice scale. Maybe this will be only a desktop study. We still don't know. Our goal is big, but as I said, we really it really depends on the companies that will be final participants on this project. And the general outcome that is expected is to have a comprehensive understanding of grid behavior during the BEV charging, is strategizing on balancing demand and ensuring stability, producing possibly some electrification guidelines, even though we are active with that and we are currently producing guidelines and white papers with the Subspace Energy Hub, and also in general enhancing safety, energy efficiency, and systems reliability. And lastly, I would like to mention some key messages from this presentation today and also from the current situation with the electrification in mines. So I would like to sum up by saying that electrification is here, but the infrastructure is not ready. We cannot manage what we don't measure. Charging isn't just a plug-in and go, it's a system-wide event, it's a side energy event. Mines are like energy islands, stability starts locally. Smarter systems mean stronger sites. And we are not just testing, we're building blueprints for the future grids. Thank you so much, and I would like to invite now Marc-André from Grivix. Grivix is also a partner company of the Subspace Energy Hub, where he will be talking about his technology and also about the collaboration initiatives we have jointly with the Subspace Energy Hub. Thank you, and I will welcome your questions in the end after Marc-André.